Okay, quickly kind of reviewing these PowerPoints. The Poisson probability distribution, which are another category of discrete probabilities. Poisson distribution is discrete probability distribution that applies to occurrences of some event over a specified interval. The random variable x is the number of occurrences in the event in a particular interval. The interval can be time, distance, area, volume, or some similar unit. This is the formula that you can use, and of course, we have the calculators with StatCrunch or your TIs will do it also. The requirements for the Poisson. The random variable x is the number of occurrences of an event in some interval. The occurrence must be random, the occurrences must be independent, and they must be uniformly distributed over an interval being used. Uniform distribution. And then they give you the various parameters. The mean is mu, the standard deviation is just the square root of the mean. So there you go. It's pretty simple to work with that. A particular Poisson distribution is determined only by the mean, and a Poisson distribution has possible values of 0, 1, 2, so forth, with no real upper limit. There is not an upper limit here, and that's kind of key too. Okay, let's assume that the Poisson distribution applies and that the mean number of hurricanes in a certain area is 7.5 per year. Find the probability that in a year there will be 5 hurricanes. Okay, well, let's get over here and let's pull up StatCrunch. Let's see if we can get it to cooperate with us here. You can access StatCrunch without it just immediately pulling up. All right, if we go to Stat and we go to Calculators, and we're looking for Poisson this time, and there it is. Now let's see what all it asks for. It asks for the mean. What is the mean? The mean number of hurricanes is 7.5. So let's put that in. And then it says find the probability that in a year there will be 5. That means exactly 5. So we want to change this to equals, and we want this to be not 15, but 5. And then we compute it. Okay, what did we get? Our answer down there to one decimal place is 0.109. Okay, the expected number of years with 5 hurricanes is what? Okay. Okay, B does say in a 35-year period, how many years are expected to have 5 hurricanes? All right, over 35 years, and it's what? 7.5 per year. So let's see, how would we go about doing that? We will probably take this answer and multiply it by 35. So let's get us a calculator over here. And let's take the 0.109 times 35. Okay, one decimal place, so I would say that's 3.8. Okay, so what was the expected number? It was the probability of the 5 hurricanes in 1 year and then multiply it by the 35 years. The results from part B is close to or different from the number of hurricanes in the recent 35 years. Well, what are we comparing to? How does the result from part B compare to a recent 35 years in which 3 years had 5 hurricanes? Does it work well? Well, that's pretty close to it, 3 and 3.8. So the Poisson does appear to work well in the given situation. Okay, that's the way that problem would work.